Hey devs, welcome to the channel. Today we're talking about vertical slice architecture. And what we're going to do is we're going to set up a project using minimal APIs. We're going to map those APIs with Carter. We're going to use Mediator for CQRS, Fluent validation with a custom exception handler for our validation, and then we're going to add that validator to our behavior pipeline in Mediator. Then we're going to take all of that and bundle it up into a template so that we can then use it to spin up new APIs in the future. Let's get into it. To start off, we're going to go ahead and create a directory to hold this, and so we'll just call this vertical slice.template. We'll launch code. So now we're going to create our .NET project with Control-Shift-P. We're going to say a new project. We're going to create this as a empty web API. We're going to call this vertical slice.template in the default directory. Now what we want to do is we want to go ahead and add a couple of packages to this project. So to do that, let's just get into our directory and then do .NET add package. And the first package we want to add is, let's just go ahead and add Mediator. Let's also add Carter. Then let's add Fluent validation. Gotta spell it right. And then let's go ahead and add ASP versioning so that we can version our API. And then we're going to add MVC API Explorer so that we can make our API work with Swagger and inject the version into our routes, our URL routes. Let's just double check in our program, make sure everything got installed. Everything looks good there. Let's go ahead and add a global using.cs and just say global using Mediator, global using Carter, global using Fluent validation. Save that. And then in our program, when we're registering our services and things like that, let's start off by getting our assembly. Let's do builder.services. And here we're going to add Mediator. And we're going to register from assembly and then just use our assembly. Then let's go ahead and builder.services.add Carter. So let's go ahead and set up our API versioning as well. And we'll say builder.services.add API versioning. And with this one, there's a couple of things we could do. We want to set our default API version. So let's say new, let's go ahead and add this to our global using the ASP versioning. In our program, we're going to say new API version, and we'll call this 1,0. Let's also say API version reader equals URL segment version reader. Then let's also specify that if no API version is specified, we're going to assume the default version. Also report our API versions. Then we will tack onto this our add API Explorer, and these options will allow us to inject this into the URI. So we'll say options.group name format, and we're going to say v is replaced with the version, and then options.substitute in URL is true. So that way it will map our URL for us. We'll have to come back to this to set up a few other things in the future, but let's go ahead and just to finish this up, let's create a version set. So we'll say var version set equals a new, oh no, not new, app.version set. This is where it's a new version set. And then we can say has API version 1. And if you add a new version to your API, you would say has API version 2. And then you could do .build. This needs to be new API version 1. That IntelliSense is not always your friend. So that's our API version, right? And now the cool thing is we can create a route builder from a map group and specify that our version is our API version, and so then that will utilize our version set to replace that URL section. And so then we can use this route builder. Always got to spell it right. Always got to spell it right. And so then now what will happen is anything we map with Carter will be prefixed with our version. So now we want to go ahead and set up just a basic feature folder inside our feature folder, we could create a template item so people know to delete this folder. And so inside this folder, we'll do a create item. And then inside that, we'll create a create item endpoint.cs. And we'll also create a create item handler.cs. So now in our create item endpoint, what we want to go ahead and do is add a public record for create item request. And again, these are just examples. And when you're using minimal constructors, these create properties. So I always like to case them in Pascal case because they're properties. And that's kind of what I do. So now we're going to say a create item response, and we'll just do string item name. So that's our request and our response. Now we need a create item endpoint class, and this class is going to inherit from iCarter module, implement the interface. So I do control period while hovering over that and just say implement interface. And now we're going to say app.map. This would be a post because it's a create an item. And so then we'll call this black item. And then this is going to come in with the string item name. And so then what we can do is we can just do a return results created. And then for the URL, item/item name. And then we will just pass in the item name. So we're just making this async. Now it does lack an await operator, which is why we're getting this little warning here, but in reality, we would probably have an await operator. And this is just to set up our template so everybody knows, and theoretically this should be deleted. It's just used as an example, right? So then the other thing too we want to add here is map to API version, and then we're going to say version 0 because this endpoint is for API 0. So that kind of sets that up, right? Now what you could also do here is you could say produces and then add the status codes dot, and it's going to produce a 200 created if it's created, and then produces problem is going to create a status codes, and this would be a 401. And then you can even add a summary with summary and say creates an item. It just helps people who are utilizing the API. And again, this class should be deleted, but it just kind of gives everybody an idea of, hey, this may be how you want to kind of configure, because this is our template. Now we're going to go ahead and create our handler. And so here we're going to create two records as well, a public record create item command. Now this is going to inherit from iRequest, which is from mediator. It's going to return a create item command result. And this doesn't exist, right? So we got a little bit of a problem there. So we're going to create another public record that is our create item command result. And then we're going to create our handler. So now we're going to create our internal. We're going to create our internal class, which is our create item handler. And this is going to inherit an iRequest handler that takes in a create item command and returns a create item command result. And then we have to control period and implement the interface. And so then that creates the interface implementation. This is where you would create the item that you're trying to create, add it to the database, whatever. So what we're going to do though is we're going to return a new create item command result with just the request.item name. And so that's all we're going to do for our basic example, right? We also want to go ahead and just in here add a public class create item validator, and this is going to inherit abstract validator for a create item command. And then we're going to create a constructor, and inside this constructor, rule for and the rule is for the name, right? Because it's the only property we have, item name, not empty, but then we're going to say with message, and then we're going to say item name is required, or you can make it just a little bit friendlier. And so then this is how our validation is processed using Fluent Validation. Next, what we want to do is make sure that validation is processing, and in order to process that validation, we need to create a custom exception handler. You could create a new folder with for exceptions, and then inside that folder we could create another folder for handlers in case you have multiple. And so then we'll just add and we'll call this custom exception handler. Really, ideally, I think you'd want to extract this out into a different library, so then you have that separate library that is just pulled in, just like your versioning library is pulled in or something like that. But since I don't have a place to put that library at this point in time for the template, I'm just going to include it in the template. So inside here, we're going to say public class custom exception handler, and this will inherit logger custom exception handler. I'm sorry, this is not inheriting, it's injecting. Dependency injection will inject a logger in there, and what it is actually inheriting is an exception handler. So we're going to go ahead and inherit the exception handler, and it is upset because we haven't implemented the interface, so we're going to do that. We're going to implement the interface, and then first line in the interface we're going to say logger.log error, because this is our exception handler. Well, let's go ahead and log the exception, and then we're going to log a message with the exception. And for the message, let's just say error : and then we'll say exception dot get type name, and let's go ahead and log the exception message. So we'll just log those two things. So now what we want to do is control what status code is returned based on what exception is thrown. So we'll say var status code equals exception switch, and then if the exception is a validation exception, then our status code is going to be a 400 bad request. And if it is anything else, which underscore is our default, if it's anything else, we'll say status code, and we'll do a 500 internal server error. Okay, now we want to return all our validations to the front end so that they could be processed. So to do that, we're going to create a new problem details, which the title can be the exception message, right? The detail could be the exception. Actually, let's make the detail the exception message. Let's make the title the exception type. So we'll say exception.getType name. So the title will be the name of the exception that's thrown. The detail will be the message that it is. The status will be the status code that we created and populated. For the instance, we'll use the HTTP context and get the request path, and then if the exception is validation exception, then what we'll do is we will add onto this problem. The problem has extensions, so we're going to add an extension. We'll call this validation exceptions, and then we'll say validation exception dot errors. Now we want to write this to the HTTP context as JSON async, and then also pass in the cancellation token, and then we're going to return true. So that'll go ahead and populate our exception message, but now we need to go ahead and make sure that we're using that exception message. This does not need to be in parentheses. Okay, so at this point, I want to add the validators from the assembly, which is all those abstract classes with the rule 4. I want to add those in. And I was trying to do it and I was struggling with it. Couldn't figure out why. And I realized that I forgot to add a package, which that does happen, right? So we will also want to add fluent validation.asp.NET core. Now once that gets added, we should be able to say builder.services.add validators from assembly, pass in that assembly variable that we created. Then we'll say builder.services.add exception handler, and then this is going to be that custom exception handler that we created. And then what we want to do is we want to also inside our app say app.use exception handler, which I think it's a pass in the options, and then this doesn't need anything, just that, and that should be sufficient. Now the only other thing we need to make this work effectively is we need to run those validators. So to do that, we need to add a behavior from mediator. And so this allows us to tell mediator, hey, before you execute that handler, run this validation. So what we do then is we create a new file and we'll call this validation behavior. This class is going to be a public class validation behavior. And then it's going to take in a type of request and a type of response. We'll go ahead and create a minimal constructor, and it's going to accept an IEnumerable of iValidator, which also has a type of request, and this is our validators. And then this is going to inherit the iPipeline behavior from mediator, which also takes a the type of request and the type of response. And this is where the type of request is an iRequest with a type of response. So this just makes sure that this is all run on our handlers. Now, just to implement the interface, we have to get create a new validation context from this request. And we do need to specify the type, which is request, tRequest. Now what we want to do is we want to get all the validation results. So we want to essentially tell this, hey, run all the validation. So we're going to await a task when all. So when all validators, and let's select the validate async and pass in the context, this validation context, and it also wants the cancellation token, and this needs to be async. We want to get all the errors. So if there are any errors from this validation result, so we're getting the validation errors where there is an error. So we're saying if there are any errors, then we want to select many, which takes all of those errors and makes them one list, and then so we'll specify this to list. Now we're going to say if errors any, throw new validation exception, and then we're going to give it the errors. So what this does is it makes sure that in the pipeline, before we make our request, we're going to run all those validations. If any of those validations have an error, it's going to throw an error. The throwing of that error will be caught by our custom exception handler that will then format that error and provide it as a JSON response to the endpoint of the API for anybody that's querying that section. So to get this to work, we need to add in mediator our open behavior. Then the open behavior is going to be type of validation behavior. So that's how we can set up this whole project, but let's just go ahead and add one more thing to the project so that we can kind of make sure that we're able to test it, right? So we're going to say vertical slice template.htp. And so then in here, this is an HTTP file that allows us to run our project. So let's go ahead and go into debug and create a HTTP instance that we can execute and launch the project, right? So this is going to launch on port 572, right? So inside that HTTP file, what we want to do is we want to specify a host address, which will be HTTP localhost. What was that IP? 5172, is that right? And the IP is going to be 5217. Now what we can do is we can create requests, right? So currently we only have a post request, so we'll say post host address / item. This is going to accept application JSON. The content type is going to be application JSON, and then the body is going to have item name. We're going to send one with nothing, and then let's go ahead and send one more with a name. So we'll hit send, and then you could see, oh, hang on, let's see what our actual endpoint is. Oh, we got to do v1 because we're using URL routing. So then we get a bad request, and then you can see here is parameter string name is required. And then if we hit send request, okay, let's take a look at our endpoint, and you can see here it is just expecting a string. Oh, the problem is this should be a create item request. And so this is item, and then this is going to be item name, and then this will be just item. And now if we send the request, we get a 200 created, send request, 200 created. Clearly we have an issue here, right? Because it's not running our validation. So let's just take a look at that real quick. If we go to our handler, let's just go here to item name, put a breakpoint there, run this again. Yeah, and you see it didn't run our validation. So let's just troubleshoot that real quick and see what's going on here. Let's make sure it's running our handlers. Doesn't look like it's actually running our handler. Oh, this needs iSender. Sorry about that. That's a total rookie mistake there. So we're going to go ahead and then var response equals wait sender.send. And we actually have to send a command, right? And this is currently a request. So what I'm going to do is I'm going to just do this. You can use a mapping utility like AutoMapper to do this, but what I actually like to do is just create a public create item command and then convert to command. Again, you could use AutoMapper, but I like the explicit mapping here so that I can easily see it, understand it, and make sure I know what's going on. So now with those two things, having the sender actually send the command now, and then actually let's do a response, which our response should be a create item result, and this is result and then response, and then we would say equals new create item response, which this to me is where AutoMapper would be nice, because now your create item response needs a method, or you would need to follow the adapter pattern at this point if you didn't want to use AutoMapper and create an adapter that would convert a result to a response. So at that point you kind of have to decide, you know, what solution you want for your specific implementation. So now if I send the request, you can see we're hitting the rule, we hit continue, and we get the full on error, the validation error, and then here we have the exceptions with the property name and the error message. And if there are multiple errors, they will all show up here. So now if we go back to our HTTP and we send the actual valid request, you can see that it comes through, and we have our item name that's returned with the test name. Now all we have to do is take this project that we have set up and convert it to a template. So to do that, we'll just go ahead and add a folder. This folder is .template.config, and then inside the template config you're going to add a template.json. All right, so let's talk about this template file right here. The schema property just sets the standard schema. You set who the author is. The classifications set just like the type of projects that you might use it on inside the template list. Source name is what actually gets replaced, so it'll search through the entire project, and anything that matches that, it will replace it. Name is the name of the project. You have a nice description, and then the short name. So to install this, all we have to do is .NET new install and then period. And we can do that because if you look, we're in the folder with the template config. So we do .NET new install period. It's going to install the template, and then you can see there we have the template name, the short name, and then the tags, which you can see are the classifications. So then what we can do is we can, if you say .NET new list, it will list out all your templates, and then you can see your template here, the one we've just added. So then if we were to create a new directory, and we go into this, we can say .NET new VSA, which is our vertical slice template. We can give it a name, like let's say we're just calling this our products dot catalog, something like that, right? Then it's going to create it correctly, and then you can see there in it, it renames everything. Now it did rename our solution because our solution isn't vertical slice dot template. So what we could do then is, if we want to fix that, we can go back to our vertical slice template. We can do .NET new uninstall period that, and then we say .NET new list, and you can see that the template's no longer there, it's been uninstalled. And then we could rename our solution now. If we again install the template, we'll go ahead and create a new directory again after removing that old directory. Let's just confirm that it's empty. Yeah, and so then if we say .NET new VSA products catalog, now you can see everything's been renamed. So that's how we can set up a vertical slice project and then go ahead and create a template from it, so that as we spin up new microservices, we just use our template and it's already built out with maybe a lot of the boilerplate code that we would normally want to use. A couple of things I think I could do to improve on this template is, one, break out the behaviors and the exceptions into a separate library and pull those in. I also think that my microservices monitoring video using Grafana, you could implement some of those things as well, because that would likely be something that you would use across the board in all your microservices. So if you want to check that video out, there'll be a link in the description. Thanks so much for watching this video. I hope you found it helpful. If you did, be sure and give it a like, and until next time, my cool signing off phrase goes here. Take care.